Let's talk about second order differential equations. Okay, DE means differential equations. A differential equation is just an equation that has derivatives in it. And your goal in a differential equation is to solve, when you solve a differential equation, you look for a function that would obey that equation. So for example, if I have, this is the common type of differential equation you will encounter, where you have some constant a times the second derivative of y with respect to x, okay, plus another constant b times the derivative of y with respect to x, so that's what y prime is, plus some constant c times y is equal to 0. So this is what's called a second order differential equation because the highest derivative is a second derivative. Okay? So if the highest derivative is a second derivative, we say that's a second order differential equation. The highest derivative is first derivative, then that will just be first order. Okay, so let's take a look at this one. It's a common differential equation you might encounter. Let's show that e to the sx is a solution to this. In other words, if I plug in e to the sx for y, that it will obey this equation. So let's do that. So s is a constant, so I'm going to say 1 a times second derivative of e to the sx is what? What's the derivative of e to the sx with respect to x? S e to the sx, and then take the derivative of that again, that's s squared e to the sx. So this is going to be s squared e to the sx plus b times, what's the derivative of e to the sx with respect to x? S e to the sx. And then plus c times e to the sx equal to 0. Okay, can I factor something out here? E to the sx, e to the sx, e to the sx, I can factor that out. E to the sx times as squared plus bs plus c equal to 0. So you know it's going to be a solution if there is an s that would satisfy this, right? So when two things equal to 0, either, so if a, b is equal to 0, either a is 0, right? Or b is 0, or both are 0, right? E to the sx, since x is generic, is a variable, we can say that's not going to be equal to 0. So this must be equal to 0, this expression right here. So we say then that for e to the sx to be a solution to this differential equation, in order for e to the sx to obey this equation, then it must be true that as squared plus bs plus c is equal to 0. So what are the two allowed values of s? Quadratic formula, negative b plus or minus square root of b squared minus 4ac over 2a. So there's two possible s values, okay? Unless it's a perfect square, in which case there's only one s value. And what you'll find in that case is that x times e to the sx is also a solution, okay, if it's a perfect square. But in this case, you're going to have two possible values of x. Let's call that s1 and s2. Then the two solutions are e to the s1x and e to the s2x. Okay? So let's apply that to this problem right here, simple problem. 4 times the second derivative of y with respect to x minus y is equal to 0. What are the two possible values of e to the sx? So let's just cut to the chase here. let's identify a, b, and c. Remember, this is of the form a y double prime plus b y prime plus c y equal to 0, right? So what's our a? A is 4. What's our b? 0. What's our c? -1. So s would be equal to -0 plus or minus square root of 0 squared minus 4 times a, which is 4, and c is -1 divided by 2 times a, 2 times 4, right? And that's 1. So plus or minus square root of, what is 4 times -1? 16. Right? The square root of 16 over 8. So plus or minus 4 over 8. So plus or minus 1/2. So e to the 1/2 x is a solution. And so is e to the -1/2 x. You have 2 solutions. And you plug that back into your differential equation. You plug it back in here, and here, and here. You should get 0. Okay?